Today I'm going to start with chapter one of the textbook. Which textbook, you ask? Well, in case you missed it, it's this one, Designing Embedded Hardware. So I think it's easy to get a copy if you just get the electronic one. But I think you can also get the hard copy if you prefer. But yeah, this is the book I'll be following, and today I will start with chapter one of this book, and also I will supplement material that's not in the book. This way, you can get more of a complete picture. Okay. Okay, so chapter one is really about a review of computer architecture, including embedded systems. And so embedded systems are often contrasted with general purpose systems. And there are many ways you can do this comparison. One is from the function aspect, the functional point of view. And the other is more of the non-functional aspect. Okay, so functionally, I mean, what does that mean? That means in terms of its functionality, what does it do, right? So for general purpose, what it does is it has the ability to load in a different program at different times. So you might be using it as a spreadsheet, as a video editor, as a word processor, as something else. It loads a different program in, or maybe several of them at the same time. And because you need the ability to load in a program, and programs are written for different operating systems, so the operating system matters. It matters if you're running, whether it's Windows, which version of Windows, or Mac, or Linux, or something, right? Because if you write a program for one operating system, it may not run on another operating system, even if you use the same kind of processor. And of course, there are ways to make it run, but that's a different story. But that's what general purpose computers do from functional point of view. Now, what makes something an embedded system, just from functional point of view, not necessarily architecture, but functionally, is that an embedded system usually just runs an application, one fixed application. You don't necessarily load in different applications at different times. So it does its thing, right? It always does that thing. And so what operating system you use? Well, the user doesn't really need to know that, or oftentimes doesn't have to know. And whether or not you use an operating system, or if you use one at all, that really is one of the design decisions you can make. Now, in addition to just the functional aspect, there's also the non-functional aspects that distinguish general purpose systems and embedded systems. So for general purpose system, there tends to be less in terms of non-functional requirements. So for example, when you think of a general purpose computer, you think of maybe a desktop computer, a laptop computer. And so these really don't have much in terms of constraints other than the fact that it should fit on your desk or under your desk, or you can carry it, light enough to carry, but they don't really have stringent constraints. On the other hand, embedded systems, not all of them, but most of them have some kind of implicit size constraints or shape constraint or battery life expectation or weight and heat, noise, and all that, right? So if it's something wearable, like your watch, it shouldn't be as heavy as like an iPad. That would be too heavy to wear on your wrist, right? So of course, no, this line is not always so clear, and it's blurring all the time. So if you have something like an iPad, iPhone, or tablet computer, or these newer generation devices, then some of these issues start coming into play, like the size shouldn't be too big, right? It should be lighter. People have expectation on battery life, right? And that's becoming more true with even laptop computers. Weight, heat, noise, right? But in general, I think embedded systems, depending on the application, would have more stringent requirements or constraints on these non-functional aspects. Now, in terms of architecture, that means an embedded system may need to rely more on specialization at the computer architecture level in order to achieve or meet those special requirements of the application, especially the non-functional ones. Functional, of course, right? You have to do. Now, so here is kind of a comparison from the chapter 1 of the textbook. And I redrew it slightly just to show some difference. Okay, so in the left column, you have general purpose computers. And you could roughly divide it into hardware, a firmware layer, operating system, application layer, right? These four. Of course, each layer can be divided further. Now, embedded system, right, they come in wide variety. Some of them, the high-end ones, can look very much like a general purpose system. So as you see, right, there's really no real difference between a complex embedded system and a general purpose computer. So some of these examples can be like a set-top box, and that's something you put on top of a TV, plug it into a TV, and you could watch whether the could be video from the internet, could be your own video library, things like that, right? Now, a simpler embedded system, on the other hand, may look something more like on the right. Now, of course, you have to have hardware, but what's above hardware is where you have the distinction, right? So, yes, there's a firmware layer, but the boundary between firmware and system software is usually not very clear. And in fact, the boundary between system software and application is not very clear either. So if you look closely, those are dotted lines, not solid lines. I don't know if you can see very well on the screen. But that means they could all be together as one fused unit rather than as clearly separated layers. Okay. So you ask, okay, so what's firmware and what's software? Well, firmware and software, they're both program code, and they're both what people might call software. In that, you can think of these as just different forms of program. Now, firmware is program code that is already resident or inside hardware, even before you power it on. Whereas software is something that, in this particular sense, in contrast to firmware, is the part of program code that gets loaded in after you start running. Okay, and it could be loaded in by firmware, or the firmware could load an operating system, and the operating system then loads more application software and so forth, right? So firmware is something that is retained after you power it off, right? It's still there, and next time you power it back on, it's ready to run. So firmware is basically the sticky part of your system, and it could be upgraded in most cases. That is, sometimes you might want to do a firmware upgrade. Like sometimes your AP at home, right? Your access point at home, or you may have a GPS unit, or you may have any one of those devices. Sometimes you get a firmware upgrade. Whereas software, well, that gets loaded in either by the firmware bootloader or by OS into the RAM before it runs. Okay, so that's really the quick comparison between firmware and software. And there could be a difference depending on what kind of system you're talking about. Now, firmware in embedded systems, could mean more, right? It could mean more than what firmware you find on a general purpose computer. So, like your PC, there's firmware. The purpose is really for it to look for ways to uh, what they call bootstrap itself, right? So when you power it on, it checks: is there a disk? Is there a USB stick? Is there a network connection? If so, it tries to do the basic reading from there. Read more instructions so that it can then load in more stuff, right? That's called bootstrapping. And that's really what a firmware for general purpose computer does. Now, but for embedded system, it could be more. So it's more than just the bootloader. And for embedded system, your operating system could be part of your firmware, so that when you power it on, it already has the OS ready to go. There's no additional step in loading. And that's why a lot of embedded systems, you turn it on, it's ready to use. No need, unlike a PC, you turn it on, you sit there, ding, and then wait, and then sometimes it gives you a smiley face. Sometimes it opens a window and that shows you something and wait. Right? Basically, tell you to wait, and because it's lower level code loading in more code to load in more code to load in more code. Right? Embedded systems, a lot of times, that's all ready to go. Right? That's all in firmware. Now, embedded system might not even have an operating system. It just starts running your application directly. That can happen too. So in general, there are two styles of running, whether you call software or firmware in the embedded system. The first one is what's more common today, and that's called execute in place, or XIP. What that means is there's really no loading process. Upon booting up, it just starts running. It starts running from what's called non-volatile memory, or NV memory. Non-volatile memory is what I was telling you. It's sticky in hardware. You power it off, content is still there. Next time you power it on, it's all ready to go. Okay, and you might be familiar with the term flash memory. Yes, this is tends to be a form of flash memory that stores the firmware, but it's probably not the kind you have in mind. I'll tell you the difference. Now, the other style is bootloading, and what it does is, upon turning it on, some part of firmware will copy the code from someplace. Could be over the network, could be your flash memory, could be a disk, could be something, into what's called volatile memory. That's what you might know as RAM. And after it copies it, then it starts running from RAM. And of course, this could be just enough so that it knows where to get the next piece of code to load in. Okay, so it builds a layer, another layer, another layer. Okay, that's what booting up can do, right? And so there's usually these two styles. Now, for most embedded systems with flash memory, large enough flash memory, then yes, you could, and actually, without running an operating system, then you tend to use execute in place. But if you're talking about an embedded system like a set-top box or something that even runs Linux or Android or something, right? You may have seen some of those embedded systems. Then they actually tend to use the bootloading style. They actually have firmware just enough to get you started, and then it loads the rest of the operating system from someplace else, and then one layer at a time. So we could take a look at some of these